Hi guys, how are you? As you all know that I am Junaid Mehboob from Route 1 Engineering, and this week I am bringing another video for you. In this video I will be showing you how to implement your basic logic gates into ladder diagram. So let's just start. I am going to skip all the portion of explaining the logic gates. I am assuming that you all know that about logic gates. So let's just take the example of AND gate. We all know that AND gate give high at the output when both of its inputs are high. So open your step 7 MicroWin. It's a good practice to add it in your comment box or symbol tables so that other worker or other engineer can know what you programmed all the things. So input A, I'm taking I.0.0 as input A. You can also add the comment regarding the input, and input B I 0.1 and output this will be Q 0.0. Let's go to the programming block. By a dot mean I'm going to implement AND gate, and AND gate we all know that is expression A dot B. So dot mean, for your understanding, you can think dot as a series. So two inputs A I 0.0 and I 0.1 and one output that will be Q 0.0. So let's see whether we have done the right thing or not. Compile all and export. Give him a destination and name. I am giving him as a AND. So open your simulator, and I've also selected my CPU. In the previous video you can see, you can learn how to select a CPU type. I'm just going to load the program. Yes, accept, and this loaded program. Open your simulator. Two inputs I 0.0, first input, and second input I 0.1, and one output. You can select the different colors, as this is not in English language, so I am assuming this as a red color. So let's give some text. This is output, and this is the output, and this is the A and B. So let's run the program, export, and run. Place CPU in the run mode. Yes, and run them. So and output will be high when both the inputs are high. So no output, but when both are high it should be 1. So this is correct circuitry. So now let's implement the OR gate. OR gate, we all know that it gives output high when any of its input is high. So let's remove it. And output. I 0.0 and I 0.1, and output is Q 0.0. Compile all, and let's export it as a OR. load a new program. Sorry, first we have to stop the already running program. Now load the new one. Here we also have to stop the program. So accept or and export run. Yes. So or is high when any of the input is high. So you can see that when both are 0, no one at the 0 output. So when both are on, output is high. Stop the program, close it, and stop the CPU. Let's take another example. NAND. So NAND, we see that it's the reverse of the AND. So when any of the input is 1 or when both are low, it will be high at the output. So you can do it in two ways. Everyone has its own way, so you can do it as cancel it. I0.0, I0.1 and Q0.0. Export it. So let's just first compile it. Now export it. And this is NAND. So let's load a program called NAND. Yes, I want to load a new one. And so put it here, cancel, we run the CPU, yes, and open your simulator. So it should be high when both are low or when any of the is high, but when both are high it should be low. So this is correct. Now let's go to the XOR portion. XOR is 1 when any of the input is high. So we can also solve it by using K-map, or you can use a logical expression. By K-map I see that A dot B plus A B bar. So stop it, yes, cancel it. A bar B plus A B bar. What is A bar B, which is I 0.0, B I 0.1, similarly I 0.0, I 0.1, and output which is Q 0.0. Let's compile it, export it by the name XOR. Okay, load the program. Yes, I want to load new one. Accept. XOR, put it here, cancel it, export it, run it. Yes. And so look at the table, it should be when any of the one is high. So 1 1, when both are 1 it should be 0. this is okay. Cancel it. So let's stop the CPU.